Imagine this. It is July 1952. The Cold War is intensifying. The United States is watching the Soviet Union. The public is anxious. The military is alert. Radar is becoming one of the most important tools in national defense. And then something begins appearing over Washington, D.C. Not in a remote desert, not over a quiet field, not above a rural highway, over the capital of the United States. Radar operators see unusual returns. Pilots are alerted. Officials are pressured. Newspapers respond. The public wants answers, and the government is forced to confront one of the most sensitive questions imaginable. What happens when unidentified objects appear near the political heart of the most powerful country on Earth? This is episode 2 in our 6-part mini-series, From UFO Files to UAP Science. In episode 1, we explored how UFO reports became UAP data, how Project Blue Book represented the old world of handwritten reports, witness forms, case files, and official explanations, and how AARO represents the new world of sensor analysis, scientific review, all-domain monitoring, and data-driven investigation. Today, we take that framework and apply it to one of the most famous UFO events in American history, the 1952 Washington, D.C. UFO wave. But we're not just going to retell the story. We're going to ask a modern question. If the 1952 Washington UFO wave happened today, what would modern radar, artificial intelligence, satellite tracking, sensor fusion, flight databases, and UAP investigation systems actually see? Would the case become easier to explain, or to become even harder to dismiss? Welcome to UFO to UAP. I'm your host Matt Tones, and today we're investigating the 1952 Washington UFO wave, what modern radar and artificial intelligence would see today. Let's begin. The 1952 Washington UFO wave is one of those cases that sits at the intersection of history, national security, public fear, and institutional uncertainty. It happened during a moment when the United States was already looking upward with suspicion. The sky was no longer just the sky. It was a strategic domain. Bombers could cross oceans. Rockets were advancing. Radar networks were becoming essential. Nuclear weapons had changed the stakes of air defense. And Washington, D.C. was not just a city. It was a symbol. The White House, the Capitol, the Pentagon, the nerve center of American power. So when unusual radar returns and visual reports began attracting attention near Washington in July 1952, the issue was never just strange lights. It was airspace. It was defense. It was public confidence. It was government credibility. And it was the fear that something unknown might be entering protected space. That is why the Washington case remains important. Not because it proves one extraordinary conclusion, not because every detail is clean, not because the historical record gives us perfect certainty. It does not. The case matters because it shows the central problem that has followed UFO investigations from Project Blue Book all the way through to AARO. A strange event occurs, some data exists, some witnesses speak, some officials respond, and some explanations are offered. But the public is left asking whether the evidence was strong enough, whether the explanation was complete enough, and whether the government was telling the full story. That pattern is still with us. It is there in the Tic Tac encounter. It is there in the Pentagon videos. It is there in the AARO reports. It is there in declassified files. It is there in modern UAP hearings. The Washington wave is not just a historical case, it is an early example of the UAP disclosure problem. What happens when an event is serious enough to demand official attention, but the evidence is not strong enough to close the mystery for everyone? That is the question. And in 1952, the tools available to answer it were limited. Radar existed, but radar was not what it is today. Aircraft identification systems were not what they are today. Weather analysis was not what it is today. Satellite tracking did not exist in the modern sense. There was no global ADS-B flight tracking, no real-time public flight databases, no modern drone registers, no commercial satellite constellations, no machine learning anomaly detection, no integrated sensor fusion environment, no smartphone videos from hundreds of witnesses, no instant open source intelligence community online checking every possible explanation in real time. The investigators of the early 1950s were working with the tools of their time, and that matters because when we judge historical UFO cases, we often make one of two mistakes. The first mistake is treating them as if evidence was as strong as modern data could be. It was not. The second mistake is dismissing them because the evidence did not meet modern standards. That is also unfair. The better approach is to ask, what did they have then? What would we want now? And how would the case change if modern tools were available? That is the heart of this episode. The 1952 Washington wave gives us a perfect test case because it involved one of the most important kinds of UAP evidence, radar. Radar is powerful because it appears objective. A witness can be mistaken, a photograph can be blurry, a memory can shift, but radar feels technical, it feels mechanical, it feels independent. If radar sees something, many people assume there must have been something there. But radar is not magic. Radar is an instrument. And instruments can also be misunderstood. They can detect real objects, they can also produce false returns. They can be affected by atmospheric conditions, they can show anomalous propagation. They can reflect from unusual layers in the atmosphere. They can be affected by equipment limitations. They can mislead operators under certain conditions. This does not make radar useless. It means radar data must be interpreted. Interpretation requires context. That is the central issue. In 1952, radar was good enough to make the Washington report serious, but not good enough, at least from the public record, to produce the kind of complete multi-layered data picture we would want today. A modern investigation would not ask only, did radar show something? It would ask, which radar? What frequency? What calibration state? What return strength? What track continuity? What altitude estimate? What speed estimate? What weather conditions? What aircraft were known to be in the area? What transponder data existed? What ground clutter was present? What atmospheric ducting conditions existed? Did multiple radar systems see the same object? Did pilots visually confirm the same track? Did infrared sensors detect heat? Did satellite systems see anything? Did radio communications correlate? Was there a chain of custody for the data? Were the raw files preserved? Those are the modern questions, and those questions show us why the 1952 case is both fascinating but also frustrating. It sits at the edge of what the old system could capture. There was data, but was there enough data? And that is the key. A question for you. If a UFO case is supported by radar, but not by modern videos, satellite data, or full sensor records, is that enough for you to consider it credible? Add your answer in the comments because this episode is really about the kind of evidence we should trust. Now, let's place the Washington wave inside the larger 1952 context. The early 1950s were filled with UFO attention. The term flying saucer had already entered public culture after the late 1940s. Roswell happened in 1947. The Air Force had already moved through Project Sign and Project Grudge. Project Blue Book would emerge in 1952 as part of the effort to collect and evaluate UFO data. The country was in a strange psychological space. On one side, Americans were living through Cold War anxiety. On the other side, they were entering a technological age where aircraft, rockets, radar, nuclear systems, and science fiction were changing the imagination. The sky was becoming a place of both possibility and fear. So when reports emerged over Washington, the case immediately carried symbolic weight. If unknown objects could appear near the Capitol, then the question was not simply what they were. The question was whether the government could protect and explain its own airspace. That is what makes this case so relevant to the modern UAP era. Today, AARO and other agencies are not only asking whether UAP are extraordinary, they're asking whether objects near military installations, operating areas, training ranges, restricted airspace, or other areas of interest can be detected, identified, attributed, and mitigated. That language is modern, but the concern is old. In 1952, the concern was already there. Unknown objects, sensitive airspace, national security pressure, public attention, official explanation. That is why the Washington case is an early version of the modern UAP problem. The technology has changed. The terminology has changed. The agencies have changed. But the core question remains. What happens when something unidentified appears where it should not? Now let's imagine the 1952 Washington wave happening today. The first major difference would be data density. In 1952, investigators had limited data compared with what we can collect now. Today, the Washington D.C. airspace environment is saturated with monitoring systems, military radar, civilian radar, air traffic control systems, transponder data, ADS-B data, restricted airspace monitoring, weather radar, satellite coverage, law enforcement reporting, security cameras, aircraft communications, potential infrared systems, potential signals intelligence, commercial flight tracking, public open source analysis, and possibly smartphone footage from many different angles. That does not mean everything would be public. Much of the most sensitive data would still remain classified. But it does mean the event would be recorded across far more systems. A modern investigation will begin by asking whether the object appeared in multiple independent data streams. This is where sensor fusion becomes essential. Sensor fusion means combining data from different sources to build a more complete picture. Radar alone may be ambiguous. A visual sighting alone may be ambiguous. A short video alone may be ambiguous. But radar plus infrared plus visual confirmation plus transponder exclusion plus weather analysis plus satellite context is so much stronger. The goal is not to make the case sound more dramatic. The goal is to reduce uncertainty. If radar shows something but no other system does, investigators must ask why. Was it a radar artifact? Was the object too small or too cold for infrared? Was it outside the coverage area? Was the sensor pointed elsewhere? Was the timing wrong? If visual witnesses report objects but radar data does not detect them, investigators must ask why. Were the objects too low, too small, too misidentified? Was radar coverage limited? Were witnesses seeing aircraft, stars, planets, drones, balloons, or reflections? If multiple sensors agree, the case becomes stronger. If they disagree, the disagreement itself becomes evidence. This is how modern UAP analysis differs from the historical UFO model. It's not about taking one report and deciding whether to believe it. It is about building a data picture. And that is exactly what the 1952 case lacked by modern standards. It had radar reports, it had visual reports, it had public attention, it had official response, but it did not have a full modern sensor fusion package. That is why it remains unresolved in the public imagination, not necessarily because the event was extraordinary, but because the data environment was incomplete. Now let's talk about artificial intelligence. Could AI solve the 1952 Washington UFO wave? The answer is not magically. AI would not simply look at a radar track and announce the truth. That's not how serious analysis works. But artificial intelligence could help in several important ways. First, AI could compare the radar behavior against known aircraft, weather effects, atmospheric ducting patterns, and sensor anomalies. It could ask, does this track resemble normal aircraft movement? Does it resemble radar clutter? Does it resemble anomalous propagation? Does it resemble birds? Does it resemble balloons? Does it resemble drone activity or known sensor errors? Second, AI could cross-reference many data sources at once. Flight schedules, military activity, weather data, temperature inversions, atmospheric conditions, astronomical data, satellite passes, radar calibration records, witness locations, timestamps, communication logs. Third, artificial intelligence could detect patterns across multiple nights. Were the radar returns clustered at certain times? Did they appear under specific weather conditions? Did they correlate with temperature inversions? Did they correlate with aircraft movements? Did they appear near certain radar coverage angles? Did they move in ways that match known atmospheric effects? Fourth, artificial intelligence could help identify witness report patterns. Were people describing the same object? Or were multiple different events being grouped into one wave? Were descriptions consistent? Did the language change after newspaper coverage? Did public attention increase the number of reports? Did witnesses near different locations report the same timing? That last point matters. UFO waves are not only physical events, they can also become social events. A sighting wave can include real observations, misidentifications, media amplification, public anxiety, and copycat reporting all at once. AI could help separate those layers. Not perfectly, but better than a single investigator flipping through paper files. This is one of the most important ideas in the mini-series. Modern technology does not simply detect objects. It also detects patterns, and pattern detection is where historical UFO research may change. The old files were read one case at a time. Modern analysis can examine them as data sets. That means the 1952 Washington wave could be studied not only as a famous case, but as a data cluster, a set of reports, a set of radar events, a set of media reactions, a set of official responses, a set of atmospheric conditions, a set of public expectations. That would not automatically solve the case, but it would make the investigation deeper. Question for you. Would artificial intelligence make you trust the UAP investigation more, or would you still want human experts, pilots, radar operators, and scientists interpreting the data? Tell me in the comments, because the future of UAP research will probably depend on both. Now, we need to be honest about the main convention explanation often associated with the Washington wave: atmospheric conditions, radar anomalies, temperature inversion, anomalous propagation. These explanations matter because they are not weak in principle. Radar can be affected by the atmosphere. Under certain conditions, radar waves can bend or reflect in unusual ways. This can create returns that appear strange or misleading. In a UFO case involving radar, atmospheric analysis is not optional. It is essential. So a modern investigation would take this seriously. It would examine temperature profiles, humidity, wind patterns, pressure, atmospheric layers, radar operating parameters, known inversion conditions, local weather data. It could ask whether the reported radar returns were consistent with anomalous propagation. It would compare the radar returns with visual sightings. It would ask whether the objects were tracked consistently across multiple radar systems. It would determine whether pilots were vectored to target that could be visually identified. It would examine whether the reported behavior matched artifacts or physical objects. This is where many UFO debates become too simplistic. One side says it was radar malfunction. The other side says no, radar plus witnesses mean it was real. But the real question is more technical. Which radar returns? Which witnesses? Which times? Which locations? Which conditions? Which systems agreed versus those systems that disagreed? What was actually perceived? What was reconstructed later? What was reported in newspapers? What was contained in official files? What was speculation and what was confirmed? That is what serious investigation requires, and this is why the historical record is so difficult. We cannot rerun the event. We cannot go back to July 1952 and capture modern data. We cannot place satellites overhead. We cannot gather thousands of phone videos. We cannot retrieve every raw sensor log in modern format. We are left with records, and records are not the event. They are traces of the event. This is one of the central lessons of historical UFO research. A declassified file is not reality. It is a record of how someone documented reality, and that distinction matters. A file can contain accurate observations. It can also contain errors. It can contain assumptions. It can contain missing context. It can contain official bias. It can contain incomplete data. It can contain conclusions shaped by the limitations of the time. That is why modern reanalysis must be careful. We should not pretend old files are perfect, but we should not dismiss them either. They are evidence of what was reported, investigated, and believed at the time, and they are valuable because they show how the government handled uncertainty. They may be the most important part of the Washington case, not only what appeared over Washington, but how officials responded when the public demanded answers. The government response matters because it shaped the public's trust. In 1952, officials had to reassure people. They had to explain that the capital was not under threat. They had to address press attention. They had to show that the Air Force was in control. But reassurance and transparency are not always the same thing. Governments under pressure often prioritize calm. They want to reduce panic, they want to prevent speculation, they want to avoid revealing defense weaknesses, they want to keep public confidence intact. Those goals may be understandable, but they can also create suspicion. If the explanation sounds too quick, people doubt it. If the government minimizes the event, people suspect a cover up. If officials say there is no threat but do not release enough data, people ask how they know. That tension is still with us today. When AARO or the Pentagon say a case remains unresolved but shows no evidence of extraterrestrial origin, some people hear caution, others hear evasion. When files are released with redactions, some people see national security protection, others see narrative control. When officials say data is insufficient, some people see methodological honesty, others see deliberate withholding. The 1952 Washington wave sits at the beginning of this trust problem. It taught the public to wonder whether official explanations were complete, and it taught government agencies that UFO cases could become public relations crises. That relationship has never fully healed. This is why modern UAP disclosure must be different. It cannot simply repeat the same old pattern. Event, public pressure, official explanation, insufficient detail, public suspicion. If the government wants trust, it needs to show methodology. It needs to explain how cases are reviewed. It needs to preserve data. It needs to make clear what is known, what is unknown, what was ruled out, and what cannot be released. That is what the old system often failed to do, and that is what the modern system must do better. Now let's consider a modern version of the 1952 Washington event. Suppose tonight unusual radar tracks appear near Washington, D.C. What happens? First, the airspace would be monitored across multiple systems. Civilian air traffic control would have one picture. Military systems would have another. Restricted airspace monitoring would add another layer. NORAD and other defense structures may become involved depending on the nature of the event. Known flights would be checked. Transponder data would be reviewed. ADS-B tracks would be examined. Military activity would be checked. Drone activity would be considered. Weather systems would be analyzed. Astronomical data would be reviewed. If the event was serious enough, aircraft might be tasked to investigate. Those aircraft might carry radar, infrared sensors, visual systems, communications equipment, and data recording. If an object was visually observed, the pilots would be debriefed. If video existed, the video would be preserved. If radar data existed, it would be stored. If multiple systems recorded the same object, analysts would correlate the timelines. If the object was near sensitive sites, security protocols would activate. If the case remained unresolved, it might enter a UAP reporting pipeline. AARO or another office might review it, depending on jurisdiction and classification. The public might not see the raw data, but the data environment would be far richer. That is the difference between 1952 and today. In 1952, the question was, did radar operators and witnesses see something unusual? Today, the question would be, which systems recorded it? How do those systems correlate? And what confidence level can be assigned to each possible explanation? That is a very different standard, and it reveals something important. Modern UAP research is not just about better cameras, it is about better correlation. One sensor can mislead, many sensors properly synchronized can reveal. That is why sensor fusion is central to the future. It is also why historical cases remain difficult. They often lack correlation. The pieces exist, but not the structured way we need. That does not make them irrelevant, it makes them incomplete. And incomplete is not the same as false. Question for you. If the 1952 Washington UFO wave happened today and multiple modern sensors confirmed unknown objects near the Capitol, would that change how seriously you take historical UFO cases? Drop your answer in the comments. Now, let's bring this back to the miniseries theme, from UFO Files to UAP Science. The Washington case is a bridge. On one side, it belongs to the old UFO era. Newspaper headlines, Cold War anxiety, radar operators, Air Force investigation, flying saucer language, Project Blue Book, public panic, official reassurance, But on the other side, it anticipates the modern UAP era, sensitive airspace, radar anomalies, military response, national security concern, public transparency pressure, scientific uncertainty, data limitations. That is why it is such an important case. It shows that the modern UAP problem was present from the beginning. The government was not just dealing with strange objects, it was dealing with unknowns in defended space. That is the part of UFO history that often gets lost. People focus on whether the objects were alien, but for government, the first question is usually more immediate. Can we identify them? Can we track them? Can we determine whether they are a threat? Can we explain them to the public? Can we protect sensitive capabilities while also being transparent? Those questions existed in 1952. They exist today. The difference is that today the government has far more tools and the public has far less patience for vague answers. That creates pressure. Good pressure, because if a modern UAP case is serious, the public should expect more than a single explanation. It should expect a structured assessment. What data exists, what was ruled out, what confidence level applies, what remains unknown, why can or cannot certain data be released. This is not unreasonable. It is the basic standard for trust. And if the government cannot provide that standard, the public will fill the gap with speculation. That is what has happened in the UFO era. It should not happen in the UAP era. Now let's imagine artificial intelligence reanalyzing the 1952 Washington files. What would it look for? It would start with time. Every report would be aligned on a timeline. When did radar returns appear? When did visual sightings occur? When did pilots respond? When did newspapers publish? When did official statements happen? Then location. Where were the observers? Where were the radar stations? Where were the reported objects? What was the claimed direction of travel? Then conditions, weather, temperature layers, visibility, cloud cover, wind, atmospheric stability, then known traffic, aircraft schedules, military flights, civilian routes, possible test activity, then language. How did witnesses describe the objects? Did descriptions match before media coverage? Did descriptions change after those headlines? Did people use the same terms? Then official classification. Which cases were identified? Which were unresolved? What explanations were offered? Were explanations consistent? Which cases had multiple evidence layers? Which cases were weak? Which cases were strongest? This is where data science could help, not by creating certainty from poor evidence, but by organizing uncertainty. That is valuable because UFO history is messy. Artificial intelligence can help sort the mess, but it cannot replace judgment. An algorithm can identify correlations. Human experts still need to interpret them. Radar specialists, atmospheric scientists, pilots, historians, data scientists, military analysts, archivists, psychologists. All of these perspectives matter, and that is the future of serious UAP research. Not one person with one theory, a multidisciplinary approach. The old UFO era often became trapped between believers and debunkers. The modern UAP era needs teams, people who understand sensors, people who understand aircraft and understand human perception, people who understand history and people who understand classification, and people who understand data. That is how cases should be analyzed. And the 1952 Washington wave would be a perfect training case, not because it can be definitively solved now, but because it teaches us what evidence we wish we had. That is one of the most useful things a historical case can do. It can show us the gaps, the missing data, the weak points, the question no one asked properly at the time. And once we see those gaps, we can design better systems for the future. That is the true value of revisiting old cases, not just nostalgia, not just mystery, system improvement. The 1952 Washington wave should make us ask, how do we make sure future events are not trapped in the same uncertainty? How do we preserve radar data? How do we protect witness reports? How do we integrate sensor systems? How do we prevent overclassification? How do we communicate uncertainty without sounding evasive? How do we make public summaries useful? How do we avoid repeating Project Blue Book's trust problem? Those are the questions that matter now, because UAP disclosure is not only about the past, it is also about building a better future process. Now, there is another important layer to this story. Public attention. The Washington case became famous because it happened where it did. If similar radar returns had happened over a remote region, would they have received the same attention? Probably not. Location changed the case. Washington made it symbolic. That is still true today. A UAP near a military base receives one kind of attention. A UAP near an airport receives another. A UAP near nuclear facilities receives another. A UAP near the Capitol receives another. Context shapes meaning, and this is why modern UAP investigation cannot evaluate sightings in isolation. Where something appears matters. Near a training range, near a naval group, near a missile site, near nuclear facility, near civilian aircraft, near restricted airspace, near the Capitol. Each context changes the risk profile. This is one of the major differences between UFO entertainment and UAP investigation. Entertainment asks, is it strange? Investigation asks, what was it? What was it doing? And why does that location matter? The 1952 Washington wave matters because of location. It forced the government to respond. It forced the media to pay attention. It forced the public to wonder whether the unknown could enter the most politically sensitive airspace in America. That is a powerful story, but it is also a useful case study. It shows that a UAP event is never just an object. It is an object plus place, plus timing, plus systems, plus public reaction, plus official response. That is the full phenomenon. The modern term UAP is useful because it widens the frame. We are not just talking about flying objects. We are talking about anomalies, events, data points, sensor records, cross-domain questions, unknowns in systems that are supposed to know. The 1952 Washington case was an unknown in a system that needed to know. That is why it remains relevant. Now, let's ask the hardest question. Would modern technology solve the 1952 Washington UFO wave? I believe the answer is possibly. A modern investigation might show that many of the radar returns were atmospheric effects. It might show that visual sightings were misidentified aircraft or astronomical objects. It might separate one dramatic wave into multiple ordinary events. It might reduce the mystery significantly. That is possible, and we should be open to that. But modern technology might also do something else. It might confirm that some returns were physical objects. It might show that multiple independent systems saw the same things. It might rule out known aircraft. It might eliminate certain weather explanations. It might identify a smaller number of truly unusual cases inside the broader wave. That is also possible. And that is exactly how modern investigation should work. It should not treat the whole wave as one thing. It should break it apart, case by case, track by track, report by report, timestamp by timestamp. Some explained, some weak, some uncertain, and perhaps some genuinely anomalous. This is the correct approach, because UFO waves often combine multiple phenomena. One person sees a star, another sees an aircraft. Radar shows clutter, a pilot sees a light. The press reports sources, the public begins watching the sky. Reports multiply. Inside that wave may be ordinary mistakes, social amplification, technical anomalies, and possibly one or two very interesting events. The job is to separate them. That is what modern UAP science should do. Not confirm the entire wave, not dismiss the entire wave, but to dissect it. This is where Project Blue Book's old model struggled. It operated case by case, but with limited tools and within a culture that often leaned toward closure. Modern analysis should be more transparent about uncertainty. It should say this subset is likely explained. This subset lacks enough data. This subset remains unresolved. This subset deserves further attention. That would be huge progress. Not because it gives everyone the answer they want, but because it gives the public a clearer map of the evidence. The UFO subject has suffered for decades from all or nothing thinking. Either it was aliens or it was nothing. Either the witnesses were right or they were mistaken. Either the government told the truth or it lied. But reality is usually more complicated. The 1952 Washington wave may have included real radar anomalies, atmospheric effects, misidentified lights, public anxiety, official uncertainty, and unresolved cases all at once. That complexity is not a weakness, it is the reality of investigation, and serious UAP research must be able to handle it. As we move through this mini-series, that will be our standard. Not belief, not dismissal, analysis. What did the historical records say? What did investigators have? What would modern tools add? What could be explained? What would remain unresolved? And what does the case teach us about the future of disclosure? That is the framework. Now, as we close episode 2, let's return to the image of Washington in July 1952. Radar scopes glowing in dark rooms, operators watching unusual returns, pilots being asked to look into the night, officials trying to understand what was happening, citizen reading headlines, a government trying to reassure the public while still facing uncertainty. That scene feels historical, but it is not gone. The technology has changed, the vocabulary has changed, the officers have changed, but the core moment remains familiar. Something appears in monitored airspace. People ask what it is. The government investigates. The public demands answers. And the evidence is never quite enough to end the argument. That is why the Washington wave still matters. It is not only a story from the past, it is a warning. If future UAP cases are not recorded properly, preserved properly, analyzed properly, and explained clearly, they will become the next 1952. Another mystery trapped between evidence and uncertainty, another case debated for generations, another file that leaves people asking whether the truth was incomplete or withheld. The goal of modern UAP science should be to prevent that, to make sure the next major case is not just reported but understood, to make sure radar data is preserved, to make sure sensor records are correlated, to make sure witness accounts are captured early, to make sure AI assists without replacing human judgment, to make sure public summaries are honest, to make sure uncertainty is explained, not hidden. Because the public does not need every UAP case to be extraordinary. The public needs the process to be credible, and credibility begins with evidence. Final question for you. If the 1952 Washington wave happened today, do you think modern radar, AI, and sensor fusion would solve it or make it more mysterious? Leave your answer in the comments. I want to hear where you stand. This has been UFO to UAP. I am Matt Tones. This is episode 2 of our mini-series from UFO Files to UAP Science. In episode 3, we will move from Washington to one of Britain's most famous military UFO cases, Rendlesham Forest, often called the UK's Roswell. But we will not just retell the story, we will ask how modern sensor fusion, radiation analysis, thermal imaging, base security systems, satellite data, and chain of custody standards would investigate Rendlesham today. If you found this episode valuable, follow the show, share it with someone interested in UFO disclosure, UAP Science, Project Blue Book, AARO, radar sightings, artificial intelligence, military encounters, and the future of government transparency. And remember, the 1952 Washington wave did not just ask what was in the sky. It asked whether the systems watching the sky were ready for the unknown.